Hello friends, this is Priyanka. Today we are going to solve a problem on slider crank mechanism. My previous video was on the same mechanism, but here angular acceleration alpha for the crank is given. So in this video we are going to consider the tangential component of acceleration for the crank. Now while drawing the velocity diagram and acceleration diagram, the main important question is that which direction that we have to follow. So regarding that, I will give you some important tips. Now while selecting the direction of rotational motion for the angular velocity and angular acceleration, there is also question. So for that I will give you some important points that you have to follow in each and every problem. So please note down that points and follow the same procedure in every question. So this is very important video, so please watch this video till end. Now first I will read what is the given problem. An engine mechanism is shown in diagram. The crank CB is equal to 100 mm and connecting rod BA is equal to 300 mm with center of gravity G 100 mm from B. In the position shown, the crankshaft has a speed of 75 rad per second and angular acceleration of 1200 rad per second square. Find the velocity of G and angular velocity of AB and acceleration of G and angular acceleration of AB. So this was the given question. Now we will first draw the space diagram with some suitable scale. Now if we observe this scale, this crank is having length is equal to 100 mm. So that is equal to 10 cm, and this connecting rod BA is having length 300 mm and that is equal to 30 cm. So we will use here this scale 1:1. So I will write here scale 1:1. Now if we observe the given diagram, this crank is having an angle that is at 120 degree. So we have to draw here first one horizontal line in the form of dash and dot, and we will select one point as a center. So this horizontal line is passing through the center, that's why we are drawing this in the form of dash and dot. Now select here the 120 degree angle and draw one line CB that is equal to 10 cm. Now from this point B, we have to take the compass and we have to mark one arc at a distance of 30 cm on this horizontal line. So take B as a center and mark here one arc. So point of intersection will give us the point A, and at this point A the slider is getting attached. Now this crank is having the rotational motion in clockwise direction, and that is also given. Now we will calculate what is the linear velocity of this crank. So here the angular velocity omega is given. So angular velocity here point B is rotating about the fixed point C. So we can say that the angular velocity of B with respect to C. So omega BC is equal to 75 rad per second. So from this omega we have to calculate what is the linear velocity. So linear velocity VBC, as point C is fixed, so we can also say is equal to VB, which is equal to omega BC into BC. So this BC we have to take in meter. So 100 mm, that is 0.1 meter. So 75 into 0.1, which is equal to 7.5 meter per second. So this is the linear velocity. So this is the magnitude of linear velocity. So how to show this linear velocity in the diagram? So we know that this linear velocity is in the perpendicular direction to the link. So here is the link, inclined link BC. Now I have to show. So in which direction we have to show? So if we observe, the rotational motion is in the clockwise direction. So in the same direction we have to draw one perpendicular line. So I will use this protractor whose two edges are perpendicular to each other. So I will align this link BC to one edge, and from the other edge I will draw one perpendicular line but passing through this point B. So along this line there is the velocity VB. So this is the direction of velocity VB, and here is the magnitude. we will draw velocity diagram with some suitable scale. So here we can say that VBC is equal to 7500 millimeter per second, and we will take scale for 1000 millimeter per second is equal to 2 centimeter. So what is the distance or length that we have to select for 7500 millimeter per second? So 7500 multiplied by 2 divided by 1000. That means here we have to take scale that is equal to 15 centimeter. So we will select one particular point. So here C is the fixed point. So I will select here the point C. Now from this point we have to draw this VBC with scale or magnitude 15 centimeter and in this direction. So I will take the roller and from this space diagram I will take the line parallel to this VB, and here I will shift this with a distance of 15 centimeter. Now here the initial point is C, and what is the final point? Final point is B. So I will use here the small letter. I will show arrow also, and this vector CB indicates us velocity of B with respect to C. So simply we can say VB. Now next we know that with this point P there is the link BA that is getting attached. Now we have to draw the velocity. Now it's a magnitude that is not known, but what is the direction of velocity? So we know that the velocity is always in perpendicular direction to this link. So for this link I will align this protractor, that is one edge, with this link BA, and from the other edge I will draw here one construction line that is perpendicular to this link BA. Now in which direction from point B that we have to project this line parallel to this perpendicular line, that we don't know. So I will take here is the line that is in this direction. Velocity of this point A with respect to point B is there. So I will take the line parallel to this and I will draw here one line passing through this point B. So now currently I don't know what is the direction. So if we observe, here is the initial point B and final point is A. Now here I will extend this line. At this point A there is the slider, and this slider is having reciprocating motion along the horizontal line, and along this line there is the fixed point C. So we can say that the slider A is having reciprocating motion along this horizontal line which is passing through the point C. So how we can show this motion of the slider? So we have to take the same direction, that is the horizontal direction only. So I have to draw one line that will be passing through this point C, that is the horizontal line, because the motion is in the horizontal direction. So I will take here, that is the one horizontal line passing through the point C. So here is the point of intersection, and this point of intersection will be point A. So for velocity diagram we will use here the small letters. So here the initial point is C, because from fixed point there is the motion of the A. So I will show arrow from C towards A, and what this vector indicates? This vector indicates the velocity of A with respect to C. So I will simply say VA, because point C is fixed. Now here initial point is B and final point is A. So I will show arrow. Now this vector BA indicates velocity of A with respect to B. So I will write here VAB. Now we have to plot the point G, which is at 100 mm from this point B. So if we observe the space diagram, BG is equal to 100 mm and BA is equal to 300 mm. So if we take ratio BG by BA, in the same way we will take here BA, and here BG is unknown, that is the location of point G is unknown. So we will write here BG by BA. So what is the whole distance BA? So if we measure with the help of scale, that is equal to 75 mm. So we will put all the data, that is 100 by 300, which is equal to BG by 75. So what is this distance BG? That is equal to 25 millimeter. So from this point B at a distance of 25 millimeter, we have to plot here the point G. Now we have to find out what is the linear velocity of this point G. So here fixed point is C. So from this fixed point we have to draw one line, that is the construction line. So I have drawn here in the form of dash, and we have to join with G. So if we measure this distance CG, then this vector CG, then it is equal to 13.5 centimeter. So with this scale, 1000 millimeter per second is 2 centimeter. So for 13.5 centimeter, what is the velocity? That is question mark. So 13.5 multiplied by 1000 divided by 2. That is equal to 6,750 millimeter per second. So we can also say that 6.75 meter per second. So this is the velocity of G. So this is the answer. Now in the same way, we have to find out what is the velocity for this AB. So for that, again we have to take what is the total distance AB. So this distance AB is 7.5 centimeter. So with this scale, 1000 millimeter per second is for 2 centimeter. If I take 7.5 centimeter, then I will get here 3750 millimeter per second, and that is equal to 3.75 meter per second. So this is the velocity of A with respect to B, that is VAB. Now from this linear velocity, we have to find out what is the angular velocity for this AB. So omega AB is equal to VAB by AB. That is, what is the distance AB? That is 300 millimeter. So we can say that 0.3 meter. So 3.75 divided by 0.3, which is equal to 12.5 radians per second. So this is the magnitude. Now how to decide the direction? So this is important point. So we have to take this, or we have to observe this velocity diagram. So here is the direction for this velocity. So if we observe, this direction of AB, vector AB is in the upward direction. So I will draw here one line perpendicular to this link AB, and I will draw the direction in the upward direction. Now if we observe, here is the point A and here is the point B. So suppose this is the velocity of A with respect to B, that is B is a center. So if I will take here the compass and I will take B as a center and then move the compass in the upward direction. So I am moving the compass in the upward direction. That means here is this is the direction. So this is the direction of velocity. So if I take B as a center, then here direction of rotation is the clockwise direction. So we can say that the omega AB is having the clockwise direction about center B. So this is the answer. Now we will move for the acceleration diagram. So before that, we will first calculate what is the radial component of acceleration and tangential component of acceleration. So we will first understand what is this radial and tangential component. So if we observe here, suppose we will consider xy is the link. Then how to calculate the radial component of acceleration? So we have to indicate a raised to r xy is equal to linear velocity square for this link xy divided by length of this link xy. So this is the formula to calculate the radial component, and it is parallel to the link xy. Then in the same way, we have to calculate the tangential component, that is a raised to t xy is equal to here angular acceleration alpha xy multiplied by the length of the link xy, and here this tangential component is perpendicular to the link xy. So from this we come to know that this radial component and tangential component are perpendicular to each other. Now if we observe, we have linear velocities that we have calculated from the velocity diagram, and here the alpha is given for this crank CB. So from this value of alpha we can also find out what is the tangential component of acceleration from the crank. So if we observe here alpha BC, that is for this crank BC, it is given 1200 radians per second square. So from this, if we put here the value of alpha and what is the length of this link BC, that is also known, that is 0.1 meter. So if we put, we will get the tangential component of this crank BC 120 meter per second square. Now in the same way, we can find out the radial component. So linear velocity for this BC is known, that is 7.5. So 7.5 square divided by 0.1, which is equal to 562.5 meter per second square. Now in the same way, linear velocity of the link AB is also we have calculated. So from this, V square AB by AB, that is 3.75 square by 0.3, which is equal to 46.87 meter per second square. Now we will move to draw the acceleration diagram with some suitable scale. So if we observe the dimensions for this radial and tangential component, then 562.5 is the large number. So we will consider here scale 1 meter per second square is equal to 1 by 25 centimeter. So if we have to convert this 562.5 in this suitable scale. So how many centimeters that we have to take? So I will take here 562.5 divided by 25, which is equal to 22.5 centimeter. That we have to take the scale. Now for the radial component and tangential component, I will use here the red marker. Now the main important thing is that in which direction we have to take this radial component. So I will write here this scale is equal to 22.5 centimeter. 22.5 centimeter. Now this is the magnitude, but what about the direction? So here C is the fixed point. So first we have to take here C is the fixed point. Now we know that the radial component is parallel to the link. So this is important. It is parallel to the link. So this is the radial component of BC and BC is in this direction. Now there are two directions for this point C, that is the downward direction also and upward direction also. So which direction we have to choose? So if we observe C is the fixed point. So for this fixed point we will take the direction for this radial component towards the fixed point or towards the center. So C is the center and point B is moving about point C. So towards the center, that is this is the downward direction. So we have to take the radial component is in the downward direction. Now only thing is that we have to take the parallel line passing through this point C. So I will take this parallel line. Now magnitude is 22.5 centimeter. So here is the point. So I will draw this. So here this is the radial component. So I will draw this line in the form of dash. So this is C is the initial point and B is the final point. So for the acceleration we will refer here as a C dash and B dash. So this is the radial component. So initial point is C dash and final point is B dash. So I will show here arrow. And now we have to take this, that is we have to give here, this is the radial component, that is A raised to RBC. So I have to write the same here, A raised to RBC. Now we will move for the tangential component. So we know that the radial component and tangential component are perpendicular to each other. So for that I have to draw one perpendicular line. So I have to draw here, that is the perpendicular line passing through this point B dash. So there are also again two directions, that is in the upward direction and here in the downward direction. So in which direction we have to draw this tangential component? So first we will find out what is the magnitude. So here tangential component is 120 meter per second square. So 120 divided by 5, that is equal to 120 divided by 25, that is equal to 4.8. So I will write here, this is the magnitude, that is 4.8 centimeter that we have to select. Now how to select the direction? So if we observe, here is the direction, that is the downward direction for this velocity for this BC. So in the same direction we have to draw here the tangential component. So I will align one edge with this C dash B dash and the other edge, I will draw here the tangential component. That is the line perpendicular to this link passing through this point B dash. So now I have to take scale 4.8. So I will take here with this scale 4.8 centimeter. So here is the point. So now this is the tangential component from this point B dash. So I will write here as a B double dash. So B dash to B double dash is the tangential component. So I have to write here, and we have to show arrow also that is in the same direction for this VB. So I will write here A raised to T BC. Now if we connect the end points of this radial component and tangential component, then we will get the total acceleration. So here I will join these 2 points. So this is the total acceleration. So for total acceleration I will use the black marker. Now in the same way again we have to draw this radial component and tangential component for this link BA. So for this link BA again we will refer here this B double dash, because B double dash is the end point. So from this we have to draw here the radial component and tangential component. So here tangential component magnitude is unknown, so we have only direction. So for radial component of this AB, magnitude is 46.87. So again we will convert with scale. So 46.87 divided by 25, which is equal to 1.87. So I will write here which is equal to 1.87 centimeter. So approximately I will take here 1.9 centimeter. So again we know what is the rule. Radial component is in the parallel direction to this AB. Now here from this point B double dash, in which direction we have to take. So suppose I will take the line parallel to this. So I am taking here the line parallel to this passing through this B double dash. So I will take in both the direction line. So in which direction we have to select. So here if we observe, here is the velocity of AB, or we can say here radial component of AB, that is the radial component of acceleration of A with respect to B. That is B is the center, and we know that we are taking the arrow towards the center. So if I take the radial component, direction is towards the center B, that is in this forward direction. So in the same way we have to take here the forward direction with 1.9 centimeter. So I will take here scale, that is 1.9 centimeter, and here that will be 0.8. Now here how we can select here the point. So from B to A. So I will take here for this radial component, I will take here the point as A dash. So I will remove this backward line. So this B double dash to A dash, which that indicates the radial component of AB. So I will write here A raised to R AB. Now what about the tangential component? So we know that the tangential component is always perpendicular to this radial component. So again there is the upward and downward, both directions are there. So which direction we have to select? So if we observe, linear velocity for this link AB is in the upward direction. So we have to draw the perpendicular line in the upward direction only. So I will take here, this is the protractor, and I will take one line perpendicular to this link B double dash A dash. So I will draw this radial component and tangential component in the form of dash. So magnitude is yet unknown, so I will draw, or I will extend this A dash. So here A dash to, now we have to find out what is the point of intersection. Now if we observe here, A is the, at point A there is the slider, and this slider is having the reciprocating motion and along a horizontal line about this point C, with respect to this point C. So we have to show this motion, that is from C to A. So how to show? So if we observe here, from this point C we have to draw one horizontal line. So I will draw from this point C dash horizontal line that is parallel to this line, or simply we can draw here the horizontal line. So in both directions if I draw the horizontal line, but here is the point of intersection, and this point of intersection, that is the end point of this tangential component. So I will say that A double dash. So from this A dash to A double dash we have to show arrow also, and for this arrow I will write here, this is the tangential component of AB. So I will write here tangential A raised to T AB, and here A raised to R AB. So this is the radial component, this is the tangential component, and we have to show here also arrow. So in this way, this is the radial component and tangential component. So if we join the end points for this radial and tangential component, then we will get the total acceleration. So if I will join here. Then this motion from C towards A, that is also the motion of the slider. So for this motion I will join with this black marker. Now we have to locate the point G in the acceleration diagram. So if we observe the space diagram, here the distance B to G is given, that is 100 millimeter, and this total distance BA is known, that is 300 millimeter. So if we observe here, for this AB there is the acceleration, or we can say vector A double dash to B double dash. So we have to measure this distance A double dash to B double dash. And now we don't know what is the distance in between this B double dash to G dash. So here we have to write one formula, that is BG divided by BA is equal to B double dash G dash divided by A double dash B double dash. So BG is 100, AB is 300, which is equal to B double dash G dash, which is unknown. But if we measure the distance in between A double dash B double dash, it is equal to 225 millimeter. So here this distance is also in millimeter, so we will take here this in millimeter. So if we solve this, we will get the distance B double dash to G dash is equal to 75 millimeter, and that is equal to 7.5 centimeter. So from this B double dash we have to take distance 7.5 centimeter, and we have to locate here the G dash. Now how to find out the acceleration for this at point G? So for that, this is the fixed point C dash, we have to join this C dash to G dash, and we have to measure this length. So this length C dash to G dash, or vector C dash to G dash, is equal to 17 centimeter. So here is our scale, that is 1 meter per second square is equal to 1 by 25 centimeter. So for 17 centimeter, so if I write here 17, then here is the question mark. So we have to make cross multiplication, that is 17 into 1 divided by 1 by 25. So which is equal to 425 meter per second square. So this is the value, that is we can say acceleration at this point G. Now we will move for the next, that is we have to find out what is the angular acceleration alpha for this link AB. So for this AB we have formula A raised to T, instead of xy we have to use here AB, which is equal to alpha AB into length of AB. So if we refer this formula, then we have to find out what is the tangential component of acceleration for AB. Now if we observe this diagram here, A double dash to A dash is the tangential component of AB. So we have to measure this vector A dash to A double dash, and which is equal to 22 centimeters. So if we convert with this scale, we will get 550 meter per second square. So now this is the 550 meter per second square is the tangential component of this vector AB. That is the tangential component of acceleration for this link AB. So alpha AB is equal to this 550 divided by length AB, that is 0.3. So this value is 1833.3 radians per second square. Now we have to find out what is the direction. So if we observe, here is the For this radial component, here is the acceleration towards P, and for the tangential component it is in the upward direction. So if I take the compass, so here the direction is from point A towards B. So if I take here the compass and I will take A as a center. So if I take A as a center and I will move the compass in the upward direction, then this is the direction, that is the anti-clockwise direction. But this is the direction when we have taken here A as a center, because the direction is from point A towards B. That's why we have taken here A as a center. So we can say that here the direction is anti-clockwise about A. About A. Now, when we take B as a center, then this direction is reverse and we can say direction is clockwise about B. So we can use any one of these answers, clockwise about B or anti-clockwise about A.